So these next couple of examples are a little bit more challenging than the first two because now we have slopes that are fractions. The process is exactly the same. We're going to start by figuring out what the given slope and the given y-intercept are. So our given slope, again, what we're multiplying by the x, negative 1/2. Given y-intercept, what we add or subtract. Our new slope will match our given slope because parallel lines have the same slope, and we're looking for that y-intercept. I'm kind of combining a couple of steps here, like step 3 and 4 I basically do at the same time. So I'm setting up my asylum equation, substituting my new slope. Remember, always with the new slope. With parallel lines, it's not essential that you remember this, but with perpendicular lines, what we're going to start looking at tomorrow, it is absolutely essential that you use the new slope. So I want you to get in that habit with the parallel lines. Use the new slope. And then our ordered pair, we're putting the -2 into the asylum, becomes positive. +2 goes outside the asylum, so it stays positive. Distributing our slope. So the -1/2 times 2, or -1/2 of 2, is -1. Combining our like terms. So we get a new y-intercept of 1, and then we're going to go ahead and graph both of those on the same set of axes. I'm going to graph my new line. We've got a y-intercept of +1 and a slope of -1/2. Make sure, as a reminder, that if your slope is negative, your line falls. I can also go up and to the left. Try and use as much of the graph as you can. Yes, 2 points does give you a line, but you've got a whole graph, you might as well use it. Plus it reinforces that rate of change. You're graphing that -1/2 over and over. So now I'm going to graph the given line. Our y-intercept is 3. Same rate of change. We've got that slope of -1/2. And then we can see that our lines are parallel. All right, one more example with the fractions and then we'll move on. Same process, I'm going to start with my given slope and given y-intercept. Slope is what we're multiplying by the x. Y-intercept is what we're adding or subtracting. New slope is the same as the given slope. And we'll have to figure out what that y-intercept is. So we set up our equation. By the way, if you write the generic equation down like I have on all of these examples, you will memorize this formula, which would be a good thing. Substituting our slope in, our new slope, and our ordered pair, we're putting that -9 into the asylum, so it becomes positive. And that -7 goes outside the asylum, so it stays negative. And we're going to solve for y. Distributing my 2/3. Alright, so I'm going to show my work a little bit here. We are multiplying 2/3. Most of you, when you're multiplying an integer and a fraction, like to write the integer as a fraction, so putting 9 over 1. And then what I like to do to simplify is remember this bar means divide. So essentially we could put these all with one bar. 9 divided by 3 is 3. So we have 2 times 3, or 6. Of course, divided by 1 still stays as a 6. Combining our like terms, we get -1 for our y-intercept. Graphing our new line, we go down 1 on the y-axis. Rising 2, running 3. And using the whole graph in both directions. And then we will graph our given line with a y-intercept of -5. And the same rate of change. And again, we get that visual reminder of those parallel lines, and it's a double check on our work as well.